All right, today I'm going to do a quick review over the difference between position time graphs and velocity time graphs. So this is one of the problems that students will often have is they will look at these two graphs, and I need to get my pen thickness right, and they'll say, okay, I've got myself a beautiful position time graph, and then they'll have another beautiful velocity time graph. And they'll have a hard time, recognizing what are the differences between these two graphs. How am I supposed to use these two graphs to gain information? So that's what I'm going to talk about right now, is how to make sure that you are isolating the information from a position time graph and a velocity time graph and not saying that they are the same. So for example, let's say that we have this beautiful position time graph that looks like this. And then the corresponding velocity time graph would look like this. So they're telling the same story, so we should end up with all the same information. But students will often end up with totally different analyses for this. So let's go to the, what is this guy? This position time graph. So if we read it directly, all right, so read directly, then we get something like, ooh, what is the position? Or what is the distance? What is the displacement? So I can say, well, I started here. All right, that's my initial. And let's just say I ended up over here. So then this is my final position. So if I want to figure out my displacement, I would read this number directly, read this number directly, and then just do a simple displacement calculation. So that'd be final minus initial. Okay, so that's how I get displacement from this graph. If I want to get displacement from the velocity time graph, I don't read it directly. I have to do that calculation. I have to say, well, if I want to get displacement, displacement represents the area. Or for you calculus people, we're integrating. So here, area equals displacement. So I would do velocity times time equals displacement. So I have to do a calculation. It's very common for students to start, going once they've learned this technique to go back and shading in triangles and things like that over here. You don't want to do that because when you're looking for displacement on a position time graph, you read it directly, you figure out your final position, your initial position, you do the calculation. When you're looking for displacement on a velocity time graph, then you shade in the area, figure out what that calculation is of your rectangle. Or it could be multiple rectangles if you have a more complicated graph. Then, the other thing that we have to remember is that we can also get velocity from these things. So if you want to get velocity from a position time graph, you have to remember the slope equals velocity. So whatever the slope of this line is, that's the worst P ever created. Slope is velocity. So in this case, I have a constant positive velocity because I have a constant positive slope. One slope, one velocity. If I go to the velocity time graph, though, I don't care about the slope of the line. Slope of the line is 0. That has nothing to do with what the velocity is. So if I read it directly, then I get the velocity. So here you can see, well, the velocity is some positive number and it never changed. So I would say, hey, during this entire time, the velocity is +2 because it never changed. So I'd read it directly. So these are the two things that students get the most confused. They will start putting one set of knowledge for the other. They'll say, oh, if I want to find velocity, I'll read it directly. Or if I want to find displacement, I have to do the area, or vice versa. So make sure you're keeping all the information for position time graph isolated and combined, and then all the information for velocity time graph isolated and combined. Okay, so remember that as we go forward, and you're going to be dealing with a lot of position time and velocity time graphs at the same time, or just one or the other. All right, so hope that helped, and enjoy your science.